Welcome, everyone, to the ABCs of Hemp. My name is Wayne Swink. I'm your host. This episode is about hemp processing, innovation, and the consequences of change. When people talk about smart agriculture, most of us think of on field agricultural innovations. We think of drones, precision tractors, soil sensors, and those technologies absolutely matter in modernizing agricultural practices. But smart agriculture is really bigger than that. At its core, it's about using data, technology, and feedback to make better decisions across agricultural systems. And we know those systems don't end at harvesting. In this episode, I want to explore smart agriculture beyond the field, using hemp fiber processing as a real world example. We're doing this not to sell a technology or push a solution, it's more to think about how innovation actually works, who it benefits, and what often gets overlooked along the way. Before we dive deeper into smart agriculture and hemp fiber processing, I want to pause for just a moment and give you a visual reference point. The next short video, titled Inside the World's Largest Hemp Processing Line: How Fiber and Hempcrete Are Made, provides a look at large scale hemp processing in action. Watching this video will help ground the rest of the episode by showing what hemp processing actually looks like at scale and why processing infrastructure plays such a critical role in how these systems develop.
Every year, the world grows more than 15 million tons of hemp to produce ultra-durable textile fibers, automotive composite materials, and even hempcrete, a lightweight, insulating, and nearly carbon-negative building material. So how do we plant, harvest, and transform this seemingly simple plant into applications that go far beyond what anyone imagined? The journey begins in vast hemp fields, where the stalks are harvested at their optimal stage and fed into processing systems calibrated with micron-level precision. The long outer fibers become premium textile material, while the spongy inner core, which makes up nearly 60% of the plant's mass, is transformed into hempcrete.
Hemp sits at a very unique crossroads. It's often described as a sustainable crop, a climate friendly material, or a potential driver for economic development. At the same time, it's a crop that many producers, processors, and communities are still learning how to deal with. There isn't a long established, mature infrastructure already in place. Uh, Processing systems, markets, standards, and best practices are really still evolving, and in some cases, they're being built from scratch. Hemp gives us a powerful lens for understanding smart agriculture. When systems are new, the effects of innovation are easy to see. You can observe who has access to technology and who doesn't, and how early decisions may impact the future. Since re-emerging as a crop, hemp has a lot of promise for sustainable textiles and biocomposites, and created new opportunities for stakeholders in the free market. One of the biggest challenges in hemp fiber production is processing, especially a step called decortication. Now, decortication is the mechanical process that separates usable fiber from the woody core of a hemp plant. Historically, that process has relied on large, centralized, and expensive equipment systems developed primarily in Europe and China. These systems are out of reach for many growers and small processors here in the United States. This is where the smart agriculture concepts start to matter in hemp fiber processing. Newer processing systems are being designed to be smaller, more automated, and more responsive to data. When we talk about data, we're talking about such things as throughput, fiber yield, and material losses during processing. That feedback allows operators to adjust machine settings, compare inputs, and improve processing outcomes over time. That right there is smart agriculture, just not in a place where most people expect to find it. So, humor me if you will. Imagine we're a small hemp processor running a decortication system. As hemp stalks move through the machine, data is being collected on how much biomass goes in, how much separated fiber and hurd comes out, and where those losses in the system are occurring. With that information, we can adjust system settings to improve time and energy efficiency. We can compare different hemp varieties for plant breeding programs. We can improve fiber consistency for our buyers, which is huge for us, and reduce waste. This is the same logic behind precision agriculture in the field, except instead of optimizing, say, fertilizer and irrigation, the process continues to be applied after harvest during fiber extraction. What this shows is that smart agriculture isn't limited to the field. It extends into processing, logistics, and decision making. One of the biggest misunderstandings about smart agriculture is the idea that it's defined by a specific tool or piece of equipment. It's easy to focus on the machine, the sensor, or the software because those things are highly visible. But smart agriculture is really about how information flows through a system. In hemp fiber processing, that system includes the grower choosing a variety, the processor handling and conditioning the material, the equipment translating plant biomass into usable fiber, and the downstream markets that decide what qualities actually matter. Each of those steps influence the others. For example, data collected during processing can shape which varieties are planted the following season. Market requirements can influence how processing systems are designed, and processing limitations can determine which growers are even able to participate in the supply chain. When we zoom out and look at it this way, smart agriculture stops being about using better technology and starts being more about coordinating decisions across the entire system. That coordination, or the lack of it, is often where the real challenge emerges. Of course, when we develop innovations, we have to ask ourselves who gets access to these kinds of technologies? In the hemp fiber industry, there are a lot of stakeholders to include farmers, processors, manufacturers, researchers, and policymakers. But as we know, access to technology isn't evenly distributed. Larger hemp operations often have the capital, infrastructure, and technical support needed to adopt new systems. Smaller scale producers, on the other hand, they lack these resources, which is ironic because they often stand to gain more from new technologies, which consequently help improve the industry's performance as a whole. This is an important reminder that innovation doesn't exist in a vacuum. The surrounding systems, policy, infrastructure, access to information also determine the haves and the have nots. When we roll out some new technology, it has benefits and it has consequences. Some consequences are obvious and immediate, others are indirect. They take time to manifest or are completely unexpected. The benefits of innovating and modernizing decorticating systems include improving efficiency by reducing energy waste, reducing equipment wear and tear, and shortening processing times. That's an intended consequence. But like I said, we also have less visible consequences. For example, If processing equipment is only accessible to a small number of actors, that value can become highly concentrated. Producers without access are going to struggle in the market. Over time, innovations meant to improve sustainability or efficiency can unintentionally widen economic gaps. And of course, these outcomes don't mean innovations are bad ideas. They simply mean that how innovations are designed, governed, and shared matter just as much as the technology itself. Now, with that being said, there's another piece of innovation that often goes unnoticed. This is uncertainty. New technologies are rarely adopted perfectly or all at once. People experiment, they adapt, they learn by doing. In hemp processing, that learning process can involve trial and error, adjusting equipment, refining workflows, or discovering that what works in one context doesn't translate cleanly to another. That learning phase is valuable, but it also carries risk. For some actors, those risks are manageable. For others, a failed experiment can mean lost income, wasted material, or missed opportunities. This is why access to support and shared knowledge is so important. Innovation requires more than just good ideas. It requires space to learn without catastrophic consequences. Systems that recognize this tend to be more resilient over time. Looking ahead, the future of smart agriculture, including hemp systems, requires better machines and more data, but it also requires that we make technology scalable and accessible, that we share knowledge, not just hardware. We think carefully about who benefits from new technologies, and we proactively anticipate consequences rather than react to them. When smart agriculture is treated as a complete system rather than a field level solution, it can support productivity, resilience, and healthy economic competition across the industry. Talking about hemp fiber processing in this episode illustrates how technology, decision making, and consequences are tightly intertwined. Smart agriculture isn't just about what happens in the field, it's about what happens across the entire value chain, from production to processing to innovation and adoption. If we want to optimize smart agricultural practices, we have to think not only about what new technologies bring to the table, but also about how they're used, about who has access to them, and what ripple effects they create. I want to thank you all for joining me on this hemp fiber processing journey. Until we meet again, I just want to say, let's continue to innovate.